In Activity 8, Making a Compass, students first observe the effects of Earth's magnetic force when they make a simple compass by floating a small magnet in water. Students then compare their compass with a compass from the kit and learn how magnetism can be used to determine direction. You will need the following materials from the kit: Activity Sheet 6, compasses, plastic dishes, dots, magnet boats, small magnets, large magnetic bar, and white paper. You will also need to provide paper towels, pitcher, transparent or masking tape, and tap water. To prepare for this activity, make a copy of Activity Sheet 6 for each student. Now, check the orientation of the compasses. The colored end of each compass needle should point north. If the colored ends do not point north, use the large bar magnet's south pole to stroke the compass needle repeatedly from the silver end toward the colored end. Locate the north wall of your classroom. Write a large N on a sheet of paper and tape the paper to this wall. Then, find a location in the classroom where students can work on flat surfaces away from metal objects. Each team of 4 students will need a small magnet, a dot, a compass, a magnet boat, and a plastic dish. Place a pitcher of water and some paper towels on a centrally located distribution table. To begin the activity, introduce a compass as a device containing a magnetic needle that is free to rotate and will react to either Earth's magnetic field or the magnetic field of a nearby magnet. Divide the class into teams of 4 and distribute the materials in Activity Sheet 6. Next, remind students that the law of magnetic attraction states, like poles repel and unlike poles attract. Explain that they will use a compass and what they have learned about the law of magnetic attraction to identify the pole of the small magnet that is like the colored end of the compass needle. Have the students hold their small magnets close to the compass. Ask them to position the magnet so that the colored end of the compass needle points away from the magnet. Put a dot on the end of the small magnet that caused the colored end of the compass needle to point away. Ask students, why do you think we placed the dot on that end of the magnet? Discuss with students how the end of the magnet with the colored dot repels the colored end of the compass needle. Based on the law of magnetic attraction, the end of the magnet with the dot must be like the colored end of the compass needle. Invite a member from each team to bring his or her plastic dish to the water station and fill it 2/3 full of water. Tell the students to dry the bottom of the dish with a paper towel if necessary. Tell the students to put Activity Sheet 6 on a level surface and to place the dish within the large circle on the worksheet. Next, put the small magnet in the plastic boat so that the colored dot is visible. They should gently float the boat in the dish of water above the dark circle on the activity sheet until the boat stops turning. Next, ask students, which way is the magnet's dotted end pointing? The dotted end of the magnet should point approximately north. Call the students' attention to the N sign you taped to the wall. Now direct the students to turn the activity sheet under their dish until the dot of the magnet aligns with the N on the activity sheet. The floating magnet in this activity responds to the Earth's magnetic field by lining up along the field lines pointing to the poles, with the dotted end of the magnet pointing to the Earth's magnetic north pole. Finally, have the students carefully remove the dish from on top of their activity sheets and place their compasses on the small, dark circle. Tell them to line up the colored end of the compass needle with the N and to fill in the other directions, east, south, and west, on the appropriate lines on the activity sheet. More advanced students may wish to insert numbers around the compass to represent the degrees in a circle. North would be 0 degrees, east is 90 degrees, south is 180 degrees, and west is 270 degrees. To conclude the activity, pour out the water, dry the containers, and return the materials to the kit. Be sure to store all magnets with unlike, opposite poles touching to maintain the strength of the magnets. Store the compasses away from the magnets. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.